Thank you so much for coming. I'm going to talk about programming healthcare well. I'll start very briefly with this WannaCry bug that you may have come across that infected lots of hospitals last week. Let me ask you, what do you think the cause of it was? Sorry, I can't hear. Outdated software. Insufficient funds? Yeah. Well, of course, what happened is the NSA found a bug in Windows 7 and the NSA was hacked. I think the causes of the problems in healthcare were first bad software and secondly bad management. Right? Here's an X-ray machine that if you have cancer or something like that, you may be scanned with one of these things. I've talked to the people who program these when you're on a course of radiotherapy. They are medical physicists and they know a lot about radiotherapy, and they don't know how to program. And they will do your dose calculations in Excel, and this is just one sheet from the Excel spreadsheet. If we had more time, I'd love to show you some bugs with Excel. And if you talk to a medical physicist and you mention words like invariant assertion, code review, they don't know what you're talking about. So I recommend you don't get cancer. I've blurred out this. It's a piece of marketing from a company that makes infusion pumps. When you go to hospital, you'll be likely to be hooked up to some drugs or saline or whatever, and there will be some infusion pumps delivering that. I've been to a company that makes infusion pumps and they sell them all around the world, and they have one programmer. And I asked this programmer two questions. I say, what happens if you have the weekend off? And I said, get yourself an apprentice, another programmer. I said, what do you do about code review? And he said, what's that? And I explained, and he said, well, I'm the only programmer, so I don't need to do code review. So, now I've set you up, I'm going to ask you a question. How are you going to die? Well, the best research we've had is you're going to die, 23% of us are going to die from heart disease, and about 22% are going to die from cancer, and then respiratory diseases, accidents, about 5%, cerebrovascular, Alzheimer's, diabetes, influenza, nephritis, and some of you are going to commit suicide, right? That's American data from death certificates about how we die. And it's interesting, 0.3% deaths are caused by car accidents. We take car safety very seriously. The best estimates we've got of error in hospitals distinguishes between error and preventable error. A preventable error is an error that should not have happened. So if I give this guy some penicillin and he's allergic to penicillin and dies, but I didn't know that, that's an error, but it's not a preventable error. But if I'm holding a piece of paper that says he's allergic and I give him something he's allergic to, then it's a preventable error, okay? And I've left a gap to put in preventable errors, right? And that's for all of the diseases, an estimate. I've spread the estimate out across all of the diseases, and if I put it in one place, that's where preventable medical error comes. Scary, isn't it? Serious harm, which isn't as bad as death, is 20 times higher than the death rate from preventable error, and non-serious harm is 100 times higher. What do I mean by serious harm? Cutting your wrong leg off, taking your own kidney out. That's serious harm, but it doesn't kill you. Non-serious harm is leaving you all night with no pain medication. I think if we improve IT, software in hospitals, we can easily knock that back by about 25%. Computers are making healthcare more dangerous, and I'm going to show you why. And fixing that, without doing anything special, just programming properly, I reckon we can reduce it by about 25%. Here's my bedside pitch. You've heard about elevator pitches. I'm going to give you a bedside pitch. Healthcare cannot survive without computers. And I put an arrow pointing to all the computers around this poorly little baby. And that's just the ones you can see. And there are ones in the background, and there's the radiotherapy computers. They're everywhere in hospitals. We need to make computers better. On most of those infusion pumps, you can see little post-it notes that the nurse has stuck on the infusion pumps because the infusion pumps are not well designed for the job of giving a baby drugs. They're little notes to remind the nurse things about the user interface or other problems. God help us if the post-it notes fall off. And we can make healthcare better, and that's really what my talk's about. Biberon are Europe's largest manufacturer of infusion pumps, and this is one of their best-selling infusion pumps. I'm going to show you something very quickly. VTBI stands to volume to be infused. The arrow keys on that user interface move the cursor left and right and increase and decrease the digits. I'm going to enter 1/100th of a mil. Okay. So I move the cursor right, happy, and I now press the up arrow to increase the dose to 1/100th of a mil. Right. The infusion pump doesn't make a noise, I think this is a bug. It doesn't know it has done the wrong thing. And if you're a nurse, you've got other things to be doing than looking at the display, like looking after the patient. If the patient dies, the log on the infusion pump will say you gave the wrong dose. And you could end up in court giving the wrong dose and you're unprofessional. I would put it to you that the program should be in court and the programmer should be in court. This is Kimberly Hyatt. She was a pediatrician with 25 years experience at Seattle Children's Hospital in America. And I'm going to tell you her sad story. She gave a baby an overdose of calcium chloride. I don't know whether you've ever made a mistake or an error, but the problem with errors is you only notice them after you've made the mistake. Because obviously if you noticed them before you made the mistake, you wouldn't make the mistake. I've locked myself out of my office frequently. I've got a staff card that opens the door, and occasionally you carry stuff in, you put it down, and you put your staff card down. And then you walk out of the office, and the door clicks, and at that moment my brain says, shit. Right? Why didn't it say shit before I locked myself out? It is something we all do, right? So Kimberly Hyatt gave the baby an overdose of calcium chloride, and she then reported it. Right? If she'd noticed she'd made the error before, she wouldn't have made it. She noticed after she had made the mistake. So this is how hospitals work. She was being unprofessional, she'd made a mistake, so she was escorted out of the hospital and put on an administrative leave, and she was then fired. Right? This is why not many people work in hospitals. And the Nursing Commission gave her a $3,000 fine, 80 hours of new coursework, and put her on probation for 4 years for somebody with 25 years experience. I think this is really sad. A different world, she might have been employed by the hospital to help people make fewer errors. Or she might have been employed by the hospital to go to the manufacturer who made the equipment, like the calculator or the infusion pump, or whatever it was, that let her down. Right? Somehow she delivered the wrong dose of calcium chloride to a baby. There was nothing in the entire system that caught that error. Where was the good programming to trap errors? This story gets worse. Can you imagine how it gets worse? What would happen if you had one bug in your program and you admitted it? You're then taken out of the building, you're then fired, put on probation, and you can come back in a few years' time. What would you do next? Right? In technical terms, the patient is the victim and the carer is the second victim. And Kimberly Hyatt committed suicide. It's horrific. And I think it gets worse than this. How could it possibly get worse? The Nursing Commission closed its investigation, so we still don't know why the error happened, so it's not possible to learn from it and avoid this sort of problem again. Right? So Liam Donaldson says, we make errors, but to fail to learn from errors is unforgivable. I'm just going to try and fiddle with this. Maybe there's a giant size for microphones. Poland has a population of 39 million. How many people in Poland are going to die from preventable error? It's not difficult to work it out. It's 0.17 times 39 million, and if you use your iPhone, you'll get about 6 million people. I wondered, what about China? It's a big country, isn't it? So what is 0.17 times 1.5 billion? Okay? If you're a nurse, you do this sort of calculation with drugs every day. Anybody got an idea what it is? Shall I do it on the iPhone so that you know? Here we go. It's about 25.5 million. One person said no. This is what Apple says it is. Let me do it on the iPhone in landscape. Yeah. When I was a child in primary school, my teacher said, always do a sum twice, and if you get different answers, you're wrong. Right? Apple can do this sum twice, they get different answers, and they can't be bothered to tell the user they're wrong. Maybe Kimberly Hyatt used an iPhone to do her calcium chloride calculation. I don't know. Well, in fact, every calculator I've played with has got bugs, and if you play with them long enough, you can find bugs like this. And some of those bugs will trap users and kill patients. I think this is completely inexcusable. Programming calculators is like first-year stuff. We know how to do it. We've had calculators for a long time. There is no excuse to get them wrong. There's no excuse not to test them. There's no excuse not to use formal methods. And I find this astonishing. I've told Apple about this years ago, and I find it astonishing it's still there. Right? We need to up our game when we're programming. It's killing people, and nobody worries about it. Here's another example, which is more fun, but it's equally worrying. Did you know that you can enter numbers into your calculator like this, and if you make a mistake, Apple have got a nice feature that works roughly like that, right? You can swipe to delete. The idea is, it's a good idea, you as a user may make mistakes, so the software will let you correct your mistakes. That's a good idea. So, here we go. I'm going to enter a number. I'm going to change sign, and maybe I didn't mean to change sign, so I'm going to swipe, and nothing happens. So, the error correction software doesn't work very well because I can't correct an error I've made. I didn't mean to enter a negative number. I've tried to correct it. So I'm going to change sign to correct the error that way, and the calculator displays error. Now, I'm a computer scientist, and this is intriguing because I think probably the calculator was implemented, and then, I'm guessing, I think the calculator was implemented, and then they decided to add delete. The easiest way of implementing delete is to do a numerical operation on the number you can see. For instance, like if you divide it by 10, you get and throw away the remainder, you essentially delete the rightmost digit. And you worry about decimal points and so on, but you get the idea. You could implement delete on the number rather than on the characters in the display. So it's kind of fun, isn't it? This is displaying error. I couldn't resist. What happens when you try deleting? So you swipe, crashes. Right. Oh, I've got these slides are out of order. I'm sorry about that. This should have come after the Biberon mistake. That is a piece of advertising from Biberon. If you're a really poorly patient, you'll have an awful lot of these things connected to you. So the probability of an error happening is higher than you might have imagined. Mersey Burns is an award-winning app. And I had a look at Mersey Burns because it got a high profile as winning lots of awards and prizes, and you can download it from here. You can run it on an iPhone or Android, or you can use it in a web browser, and you can check out what I'm saying. There are some of its prizes. The idea is, when the patient turns up burnt, you may want to give them what are called resuscitation fluids because they're dehydrated and you want to connect them to an infusion, and give them some fluid. You've got a screaming patient in front of you, and you've got to do a very complicated calculation. For instance, if your hand is burnt, you probably don't need any fluids, but if your neck is burnt, you may need some fluid. It depends where you're burnt, and there's a little paper chart, and you colour it in, and then you do a calculation, and then you work out how heavy the patient is, and so on. And it will take so long. What you ought to do is start giving the infusion first, do the calculation, and then subtract how much you've given the patient, and it's a mess. So an app like this is a really good idea. It was developed by a soldier who'd been in, I think, in Afghanistan. This is a photograph I found on the web of a typical situation where in the army you'd be doing burns resuscitation. And I put an arrow on the patients in this helicopter, and not only have you got the patients in agony with burns and so on, this is a typical photograph of a Chinook helicopter. It's under fire, and it will be swinging around like this, and the surgeons are strapped down so that they don't wobble while they're doing operations on you. It's a horrific environment. So Mercyburns app is a fantastic idea. So I'm going to show you the sorts of things you can do with it. So I've given a patient, a 54 kilogram patient. The age doesn't show for some reason. It's 336, and they have got 85% burns, which is bad news, actually. And I've clicked on Find Out What's Happening, and I'm just going to scroll down so that you can see. And I think I've highlighted it here. It says give 9.18 E plus 24 mils in the first 751 hours. Have you any idea how much 9.8 times 10 to the 24 is? This is a clue. The first 24 hours, this app says, is 10 times the volume of the Earth, right? You're going to run out of infusion fluid pretty quickly. Now, I'm obviously making a sort of stupid comment, but when you're under pressure, you make mistakes, you do what the device says. Right? You lose what's called situational awareness. You get tunnel vision on sorting out the problem, and you read what it says on the display. This patient won't get 10 times the volume of the Earth. That's physically impossible without getting NASA to help. You'll just give the patient an awful lot of stuff and possibly kill them from an overinfusion. I can't resist saying it. My father died from an overinfusion, which was an error. This happens a lot. It may not be caused by Mercyburns, but it's caused by the pressure of work and the bad programming that isn't helping spot errors, either errors by the user or errors by the programmer. I'm going to give you some final thoughts. That's my eye. I want to open your eyes to these problems and help you think about them. First is, research can help. The world's in a mess, and doing more research, more science will obviously help. I'll give you an example, a very simple example of this in a moment. And then I want to ask you, and to ask everybody, just what is the reason for this craziness? And we have to fix ourselves. We're part of the problem. No, I don't know what programming you do and what you could be doing, but you could program better. I'm a professor, I teach people to program. I could do a better job doing that. And I could encourage more of my students to go and work in healthcare. None of them want to work in healthcare. They want to work in places like Apple and Google. The companies, like the ones I mentioned earlier, that either outsource their programming or have one programmer, need all the help they can get. So here's a question for you. There are two sorts of user interface that are common for entering drug doses. You either have a numerical keypad, which I've illustrated on the left, or on the right, you have a sort of up-down system to increase and decrease numbers. Which is safer? Digital meaning the numeric keypad on the left. So there's a vote for the numeric keypad is safer. Any advances on, somebody say, you're shaking your head. This guy thinks the right side is more safer. Do you want to say why you think it's safer?
Because there's less buttons to
Fewer buttons.
fewer possibility to get wrong.
Make an arrow.
Fewer possibilities to make an error on the right. Interesting. Is that fewer possibilities for the user to make an error or fewer possibilities for the programmer to make an error? Well, we did some experiments. We got in some nurses and we had a simulation of the sort of situation they would have in a hospital, and we gave them typical numbers that they would get in a hospital to give our simulated patient. And this is what we found. So the unnoticed drug dose errors they made with the numeric keypad was about 3.5%. Now these are nurses, they're professionals, and you might think 3.5% unnoticed errors is a bit high. But then the scary thing is these are errors they're not noticing, and I wonder how high your error rate is and the errors you're not noticing. It may well be higher than that. When you use the up-down keys, the same nurses are about twice as good. That's intriguing, isn't it? The question is, why are they twice as good? We did some eye tracking experiments to see where the nurses were looking. And let me stand up here, if this is strong enough. Yep. If you've got a numeric keypad, most of the time you need to look at the keypad to see what you're doing, and you very rarely look at the display. So if you make an error, often you don't notice. Whereas if you've got an up-down input, you don't need to look at the two buttons very often, and you look at the display a lot. Moreover, with the up-down user interface, the model is the number that is displayed is wrong, and your job is to correct it. So you stay there until you finish correcting it. Whereas with the numeric keypad, the model is enter the correct number, and if you hit the decimal point twice or fumble in some way, you won't notice, as that eye tracking shows, that you have made an error. So up-down keys are twice as safe. The other way of putting it is with numeric keypads, half of the patient killed with numeric keypads are killed by bad design. Scary thought, isn't it? And this is just one experiment. How much more lives could we save if we did more research in user interfaces and programming in hospitals? So that was a little eye tracking experiment, and it perhaps opens your eyes to the benefits of doing eye tracking and user interface design. What about the craziness? I don't know about other countries. Britain has just published a report called the Watchdog Report. It came out in September last year. Making IT work, harnessing the power of health information technology to improve care in England. That report says we need more computers in hospitals. Computers are wonderful. And page after page says we need more computers. And it has a maturity model. The maturity model is how paperless is your hospital. It's not how safe are the computer systems. It also doesn't distinguish between the different sorts of computer systems, like the iPads versus the patient record systems versus the infusion pumps. It just says more computers. I think it is a bizarre report because it shows no knowledge about computers, but a lot of excitement, and the assumption that just having the latest computers will solve all of our problems. We need more people like us to bring some insight into healthcare. Does that make sense? This is a national report, and Bob Watchter is an American who was brought over specially. Almost everybody on there sees healthcare computing as a consumer problem. Just run along and buy a new computer and it will solve your problems. I recently put in a research proposal to Britain's funder for doing this sort of work, and it was rejected. And one of the bits of comments I got back was this. fixing bugs in medical apps is not research. While Britain's leading funder believes there's nothing wrong with computers, we're just going to be unable to make them safer. I think it's scary. We live in a culture that ignores the problems with computers. A couple of days ago, Oxford hospitals have bought lots of iPads, and this is one of their promotional photographs. The patient doesn't look too well in the back, but it's... I met the director of IT in a hospital, and he proudly told me they had just bought 1,000 iPads for their nurses. I asked, what are you doing about what's called information governance? You know, the privacy and security of your data. And he said we didn't need to check that because the data's on the iCloud. And I said, well, you're laughing because you're thinking the iCloud may not be secure. But I said to him, if the data's on the iCloud, why do you need an iPad? And he said, well, obviously we get the data onto the iPad. So I said, well, then the data's not on the cloud, is it? It's on the iPad. And he said, oh. Right. He's a director of IT, and he hadn't thought through something I think is really quite straightforward. Right. The directors of IT in most hospitals are clinicians who get into computers as a hobby, and they get promoted, so they're surgeons or anaesthetists or whatever, and they know a little bit about computers. What they know is you go to a shop and you buy the latest kit and your problems are solved. I think if we're all honest, we'd all love a new iPad or whatever it is. Apple and Samsung and Sony have successfully trained us to love to have computers, and they stay in business because we're not very critical. I rushed out to buy a new iPhone because I was getting fed up with the bugs in the old one. For hospitals, that's not good enough. You've got to get the old one to work properly, and rushing out to buy new kit doesn't solve the fundamental problems of the crap programming. Rushing out to upgrade Windows 7s to get round the SMB bug that brought the world to a standstill doesn't solve the problem. The problem is Microsoft don't make good software, and hospitals can't tell what good software is, so they buy crap software. And then they lose track of it, and so on. And so, you know, the whole thing goes to pieces because it's badly managed, badly procured, and badly programmed. Buying new stuff isn't the solution, but it's so tempting because it's so sexy, isn't it? It's a lovely, lovely little display. Have they even done experiments to find out whether this makes care safer or not? Have they done my sort of eye tracking experiments and discovered it would have been twice as safe if they changed the user interface? I bet they haven't. I went to a healthcare conference last week in London, and there was a session called Don't Wait to Evaluate, Use It Now. The assumption is computers are so wonderful, we're killing people if we don't use them. And I said, if I came up with a drug to cure cancer, you wouldn't let me use it tomorrow. I'd have to do some trials to find out whether it actually works or whether it's got a side effect. It may be, I don't know, it only works on women but kills men. Or it only works on mice and kills humans. Who knows? You would be required to do some experiments, randomized controlled trials and the rest of it, before you're allowed to use your drug for humans in the general population who haven't volunteered for tests. Why on earth are we rushing to put computers into hospitals without doing the research to ensure they're safe? Let me give you another example. When Röntgen invented X-rays, it was kind of obvious you could see broken bones. You could diagnose tuberculosis. 10 years later, people started dying of cancer from the X-rays. Medical interventions tend to have side effects. When you put computers into hospitals, you don't automatically get an improvement, partly because the computers have got bugs in, and partly because hospitals are incredibly complicated places, and almost certainly the computer and the hospital are, in some sense, incompatible, and things will start going wrong. If they're not evaluated and tested, you have no idea. And we're living in a consumer world that doesn't want to know we have no good idea. So this is craziness. So, how am I doing for time? Conclusions. Healthcare IT is a mess and harms lots of people. Healthcare should program better, and I'd love you to get more involved in healthcare because I'm sure you're all good programmers. Right, you should be working in healthcare. Or perhaps you should be funding me too, because the British government won't fund me. Now, if I hadn't had such chaos with getting my things connected, I would have had a little video with some sound on it. So instead of showing you the video, do you want to ask any questions or raise any points in the time? I guess we've got 15 minutes left. My arm's going to sleep because I'm holding my microphone up. Yeah.
So you're speaking about a huge problem, right? But it seems like the underlying problem is really management and allowing programmers to work the way they would like to, and they would like to use best practices, etc. I worked in an environment where tech wasn't the core product. In healthcare, the core product is delivering those services. So how can tech organizations, whether it's consultants or in-house, start changing the landscape in this way? Like, do we have the power?
Do we have the power? Yeah, we could start volunteering to help and finding out about the complexity. Let me show you a story which shows how you're thinking clearly, and I'm sure everybody here is thinking clearly, but healthcare is not thinking clearly about computer systems. So let me find you a slide to show you. Denise Melanson died in 2006. I'm trying to answer your question. She died in 2006. She had cancer and she was on a chemo drug called fluorouracil. And she was what's called an ambulatory patient. She had this infusion pump and she could walk around with it, so she didn't have to stay in hospital the whole time. So she'd have a little bag of fluorouracil, the infusion pump made by Abbott, and it's great. Your bag of fluorouracil runs out, so you go back, in this case, to the Alberta Cancer Care Centre to top up. And I'll just drop this again. I must get a smaller head next time. So, and I've jumped slides. So she went back to the Alberta Cancer Care Centre and they gave her the wrong dose and she died from an overdose of fluorouracil. And so the idea of fluorouracil is you have just the right dose. If you have too little, it doesn't kill the cancer, and if you have too much, it starts killing other things. And she died from multiple organ failure because she had an overdose. Why did it happen? Well, the hospital commissioned a study, and this is what they found. The study lasted 2 hours with 6 nurses, and 100% were confused by using it, basically. 100% pressed the start button incorrectly, 40% were confused by the user interface, 60% needed hints to use it, 60% were confused by the decimal point. I don't know whether you can see, but the decimal point, to save rubber and to make the cost of this infusion pump less, the decimal point and the up arrow are overloaded. And 60% of nurses entered incorrect data without noticing. What the hospital concluded, and the Canadian Institute of Self-Medication Practices, who sort of oversee this, is the hospital must train the nurses. What I conclude from this is, why didn't the manufacturer employ people to do this study before they sold the equipment and killed people? Right? The way hospitals react to problems is to blame the nurse, like Kimberly Hyatt. And if you blame the nurse, you get rid of what you think is the problem. Right? The problem is the IT is rubbish, but nobody understands that. Nobody understands how hard it is to program things properly, and therefore, in this case, Abbott, they rush to market without doing sensible experiments, without doing proper software development, by employing too few programmers who think they're very good at it, but actually they need code review and the rest of it. We need to raise the profile of the difficulty of doing good programming. And hospitals are not our friends at the moment because it's so easy to blame the nurses. If you sack the nurse, you think you've solved the problem. Last year I was an expert witness in a large court case and some nurses went to prison because data was corrupt. And it was corrupt because it was badly programmed, not because the nurses made mistakes. So it's a really scary world we live in, and it's not going to get better until, well, you're asking me what I should do, but I'm asking you what can you do now you've heard my message? You need to go out and let more people know that programming is hard work and hospitals are buying it on the cheap. Is that a good enough answer? Okay. So, any more questions?
Well, I think the main problem is that the main corporations that develop the healthcare systems are working in so-called impulse-driven development, because management says you won't get an invoice for fixing a bug because it should be fixed before. You'll get an invoice for new features. So it usually looks like that. For example, chemistry calls you and there's a bug in drugstores, a software that, for example, checks if this drug interferes with other drugs. Well, we might fix it later, in next version, 2 years, 3 years from now. But if someone calls with, oh, I need a new feature, well, I'll pay you for it. Okay, we'll get it done in 1 month.
Okay.
And developers can't do anything with it because managements decide what will we do or what we won't do.
So I think the point here is healthcare software is driven by money, and you get money for features, not for fixing bugs. It's interesting, isn't it? Where is the underlying problem behind that? I think it's bad regulation. The European Medical Device Directive, which regulates software, it's probably written by pharmacists who understand drugs and don't understand computers. When you buy a piece of software, it comes with a warranty that says the manufacturers aren't liable for anything. So they don't get money for fixing bugs because they don't care about bugs. Cars, do you remember I said the death rate from cars is about 0.03%? Renault has just recalled one and a half-ish cars because of a bug in the software in the cars. Because the regulation of cars is very different. They're supposed to be safe. And if they're not safe, it's the manufacturer's fault. In medical devices, it is your fault for not being professional. Most hospitals sign off a contract with their suppliers that holds the suppliers harmless and also promises to use clinical judgment. The Mersey-Burns medical app, which I showed you, which gave an astonishing advice to a clinician, it doesn't just say they're not responsible for the bugs. It says if you use this, you indemnify the manufacturers against claims. The regulation that allows that to happen, I think it is just bonkers. Right? So I'll change my mind. Instead of working in healthcare, you all ought to become politicians and improve the thinking that goes behind the regulations. Because the politicians at the moment are mostly probably they're lawyers and con artists, and they don't know enough about computers. Any more thoughts? I'll show you 2 more slides then. Here's a photograph a friend of mine took. The patient record system in the background is such a mess. This clinician is taking a photograph of it to email some patient data to another consultant. For the sake of argument, he has taken JPEG 267. And if he takes a few photographs, JPEG 267, 268, 269, which one's which? This is a recipe for making more mistakes. It's called a workaround, but the workaround is a symptom of the bad design of the patient record system you can see in the background. ISO standard 14971 says you should do iterative design and you should go in and find out how systems are actually used. The manufacturers here ought to find out how things are used and start fixing the bugs in them and the design faults that are causing people to make things worse. So this guy's trying to provide a good service for his patients, but accidentally he's increasing the risk for his patients because of bad software. I'm going to drop out of that to find another good picture to show you. It is really hard to think clearly about bugs and whose fault it is. This is my illustration of that. Just before he got married, my son Isaac asked to borrow my car. This is the day before he got married, and he had a car accident. And I turned up. You can see the police in the background where he's been interviewed and so on. It's really hard to talk about the consequences of bugs. Right. So for the sake of, I'm talking about, this is a car, but let's say it was the consequence of a bug. Somebody gets harmed in a hospital because of something. Isaac had an accident. It is so hard to describe the situation without blaming somebody. Yeah. I look at this and I say, Isaac had an accident. Right? It is really hard to say, Isaac was in the car when an accident happened. We don't do that. We very quickly blame somebody. Hospitals very quickly blame the nurse who pressed the button. So this is a good picture of what happens when my son had an accident. The police said, there's an accident here every week. So the road had an accident. This is a badly designed junction where people collide every week. This is a design problem. There's a bug in the road. And it is very hard to say that. And of course, it's rather expensive to fix the road. And it's even harder for the town to agree that they made a fault and they want to change the road, because nobody sues the council for bad road design. This is a problem with me and the other driver. Right? The law ends up blaming the drivers, not the road. But the driver set Isaac and the other people up to have an accident. Do you remember I said that improving design could probably reduce healthcare deaths by about 25%? Did you know, next slide, about 50 years ago, I was interested in this, if cars had an accident at the same speed, I would have turned up to find my son something like this. We take safety in cars seriously. Right? And Renault and other people recall cars that are unsafe. That does not happen in healthcare. My son walked away from that accident uninjured because of crumple zones, airbags, ABS, rigid frames and energy absorbing seat belts. People have decided to engineer cars to be safer. You can still have catastrophic accidents where everybody dies, I admit that, but this accident would have killed somebody 50 years ago, and improving the engineering has made it safer. The engineering has improved for two reasons. One is the regulation has improved, and secondly, the manufacturers have gone from saying drivers have accidents, which is where we are in healthcare at the moment. Nurses make mistakes. The manufacturers have gone from saying drivers have accidents to saying drivers have accidents, therefore we must make safer cars. It's time healthcare, I would like you to go out of here and encourage healthcare. Everybody should say, sure, nurses have accidents, but let's make safer systems so that those accidents don't turn into catastrophes.
For for example, you have some kind of validation that checks if user entered too high value. But it's possible in real world that sometime this value will be needed over this max limit, and you put a warning sign for the user, and he will click it without reading it at all. You can make it 3 times yes, no, switch sides, and always keep
Okay.
yes, yes, and never read it.
So the chap here has said sometimes the user will ignore all the help they can get and they will still make an error.
Yeah.
Right, that, I'll agree, that is true. That is true 50 years ago. Do not use what you're saying as an excuse not to improve.
It's something that's not an excuse, but
Yeah.
problem that most people that work in healthcare are probably middle-aged till maybe closer to retirement, just from my experience in previous work in healthcare. And there are all people that never use computers. Smartphone is some space technology for them. They will never read that something is on screen now. Only press OK, OK, OK. It's the only thing they know, and they learned 30 years ago about something, and they won't learn something new. I know this problem with management in those hospitals, and those people should be trained by also IT professionals that created the software. But I think this problem will maybe not be gone in some time, but it will be reduced significantly when the younger generation will be using the software. Will be more used to it.
You're right, and you're only half right. I don't know, I learned to drive 30 years ago, and everything I learned about driving is still valid today, even though the cars now have a few hundred computers in and they had none when I started driving. Cars have been designed to make it safer for users, more energy efficient and everything. ABS brakes would be a good example. They've got lots of computers in. Neither of us need to know how they work because they're well engineered. Whereas if you're in a hospital, you'd have 50 features to fiddle with before you slam on the brakes. So I sort of agree with you, but I argue more strongly that more thought going into design will make it a lot safer. And at the moment, we just produce stuff like those iPads I showed you earlier, and very little thought has gone into making them safer because they're so exciting. So, there's a lot to do today, but I hope you go around and spread what you have learned from my talk, and I hope what you've learned is more good programming needs to be done in healthcare, and if you do that before you get ill, that would be a really good idea. So, thank you very much.